Good afternoon, everyone. On behalf of agricultureinformation.com, I'd like to invite the speaker, Dr. Sidharth Arora, who will talk about my experiences in agro-industrial waste valorization. I now request the speaker to begin. Thank you.
Thank you, madam. And good afternoon, everyone, and welcome to Fermentech Labs Private Limited. Myself, Dr. Sidharth Arora, and today I'll be sharing my entrepreneurial experience. So, a brief introduction about myself. I'm a uh, biotech engineer by training, and I have done my PhD from IIT Roorkee in the field of bioprocess engineering. So during my doctoral research, my aim was to develop a new type of bioreactor which caters to uh, agricultural residues. So the main principle is the solid state fermentation. And through solid state fermentation, my job was to convert these agricultural residues into high value bioproducts like enzymes. So in order to facilitate that, we developed a new type of bioreactor, which provided the controlled conditions of temperature, humidity, airflow rate. And subsequently, we scaled up the bioreactor through this venture called Fermentech Labs Private Limited. And currently, we are providing enzymes. We have four products as enzymes, and we are uh, catering to primarily textile industry. So I'll be, speaking on some of the learnings that I have, gained over the last, 7 years in this space. So this will include like, certain topics like what are the key questions that you need to ask yourself if you want to be an entrepreneur. Then what are, stages of funding or key traits of an application, especially in the, agri-tech space where you are looking forward to valorize some agricultural residue. So what are the key points or key traits that, you need to highlight in the application. Then we'll quickly go through, some of the funding options available on the government platforms, and then we'll, discuss in brief the Fermentech story, what we have been, doing, and something on our products. So, what are the key questions that you need to ask yourself if you are an aspiring agri entrepreneur or agri biotech entrepreneur? So there are certain key points that you need to be uh, you need to take care of. So I call it by a press model. So basically, first and foremost thing is the problem statement. So you have to identify what is the most pressing, problem statement. And the best way to kind of ascertain that is to kind of conduct a lot of interviews with these stakeholders. Like we know that stubble burning is a huge pain point. Every year, lakhs of tons of this stubble waste burning results in detrimental air qualities in our cities, and farmers are also penalized. Likewise, there are so many waste which are also incinerated in the industry out in the open field, and sometimes they are also subject to land filling. Like we went to apple juice production plant, and we saw that during the crushing season around 60 tons of apple pomist was generated daily, and that was subject to land filling. Likewise, the textile industry, they process a lot of cotton, and there is a waste called cotton spinning waste that is generated. So again, that is subject to landfilling or sold to scrap dealers at a very low cost. Likewise, in our country, we have numerous amount of waste that is mostly incinerated or landfilled. So that is a pressing problem statement, and you need to identify, you know, the particular amount of waste which is creating the most pain point for the industry or the source. Then now you have got the waste. then you want to kind of, make some byproduct out of it, or you want to make some commodity or a product out of it which can give you revenue, right? So the business model associated, on the conversion of that raw material into the final product is also very important. And you have to, at each stage, even at the ideation stage, then at the prototype stage, then at the MVP stage, or at the commercialization stage, you have to keep on, revisiting the business model if that is, making sense or not. Then, for this, if I give an example, if I am making, a very low cost product from, say, an agricultural waste. Okay, if I'm making straws out of the agricultural waste, and if my cost of production is too high, uh, and the cost of the final product is quite low, and the substitute is readily available, so it is sometimes not advisable to kind of invest in certain amount of in this type of business. However, if your technology is much more advanced and it is scalable, these points will come later, then obviously it's a different perspective. But usually, when it comes to agri waste, we usually try to focus on certain products which are, giving higher returns. So this gives a comfort zone to the investor, which then, is more comfortable in investing in your venture. So the revenue part or the business model part is very important. Third is the entry barrier. Whether do you have a patent or a protection for your technology, so that it should not be easily, uh, copied. So another very important aspect is the availability of a patent or an entry barrier in your venture. Then there are two S. One is the scalability. Is that, can you, starting from say few kilograms of the raw material, can you make it scalable to say few tons, right? Or is it that if your technology is very much limited to a certain geography and cannot be, scaled to another geography, or can it be scaled to another geography, or can it be scaled to a different type of agricultural residue? So that those are also key questions that you need to kind of focus. And finally, is the size of the market. The size of the market should be significantly large, so that the investor is again comfortable and is assured that they will have sufficient returns against their investment. So that is a press model that we follow at each stage. So this is one thing which you can also use in your journey in the entrepreneur space. So there are different stages for the product development. First is the obviously ideation stage, where you are conceptualizing the idea and you do not have the proof of concept. Second is the conceptual stage, where you start working on the proof of concept and it has a considerable risk involved. So it is this stage where you need to do a lot of risk assessment as well. Then comes the startup phase, where you do a lot of lab scale testing on your product from the agri waste. Then you generate a lot of data, you collect feedback from various stakeholders, and then based on those feedbacks you then do follow on process optimization for the technology. Then comes the developmental phase, where you do a lot of field trials, and you kind of scale up the process and the associated planning involved. And finally is the commercialization or the growth or the expansion phase, which involves the bulk manufacturing and further technology upgradation. So this is the stages of various product development. So now what funding, is right for you. So it depends whether, you what stage you are at, and whether you are a, student, whether you are a startup or you are already an MSME. And this, kind of dictates the range of funds or the type of funds which are, suitable for you. So initially, as you know, it starts from, help from family, friends, and relatives, and then the next step is to, have access to the government funding. So the best way to, access these funds is to get incubated. There are lot many agencies like DST, DBT, MIT, PSU, then even some international programs like GITA, which is Global Innovation for Technological Alliances. So these, schemes, these department has many schemes which supports you as a student also. So this is the early stage, usually 0 to 2 or 3 years, and the ticket size is usually less than 1 CR for the deep tech or agri tech space. And then following to that early stage, you have funding from the angel investors, and then various PSUs also come and support. So there the ticket size is usually less than 5 CR, and this is like sorry, this is like 2 to 4 years when you have reached a certain TRL level, or the technology readiness level. So this stage is usually when you are at the late startup phase or the early development phase, where you get support from the angel investors and even the PSUs. And then when you are at the developmental stage, and you are entering the commercialization phase, you get access to funds from various venture capital houses, then institutional funders, then finally IPO. So these are the stages, and the ticket size in the matured stage, as you may have known, that it is more than usually $1 million. So now I will, quickly go through like some of the key traits of an application, especially in the agri biotech space, uh, because it involves a lot of, trials, a lot of iterations to convert agricultural waste into some value-added product. So there are, certain key points that I have learned in my journey, which I would like to share. So whenever you are, uh, like presenting an application, so the problem statement, as I've already mentioned, it is very much desired that you can, if you can, share the, viewpoints of the stakeholders which are experiencing the pain point. Right. So following to that, the solution that you are offering, so it is highly desirable that you have some preliminary data. And whenever you are going out to the field, right, so it is important that, if you can get some real time images or some test reports or even a partial industry validation for your solution, so that speaks volumes. And if you have a intellectual property, so it increases your chances of getting selected many times higher. So make sure that your solution is reflecting these points. Then the competitive landscape is also very important. You must understand who are the competitors in this space, and try speaking to your customers to kind of know the features that you may want to add vis-a-vis what is your competitor offering. Identify the pain point, and work where your technology needs to kind of stand apart. So next is the business model. Then you should have basic knowledge on the finance aspect. Then your cash flow for the business. Then what is the expected break even time? Say if an investor is investing, So he wants to know that, when the break even will be and when he will be starting to get the returns. Then obviously the associated capital and the operational expenditure, which is capex and opex, for the production and the costing of your product or the process. So continuing on that, the go-to-market strategy or the customer acquisition strategy. So, if you are a first-generation entrepreneur, you need to kind of, collect feedback and advice from people who have already worked in industry, have spent many years in the industry, or are kind of consultant to these industries. So in our case, interaction with the management professor helped us a lot. Then you can always interact with the industry experts, use LinkedIn and your college alumni database to connect with more and more such individuals. So they will kind of provide you the right advisory or the go to market strategy for your product. Then comes the market research. Do refer to various market research reports, scientific research to claim on the market size and projections. Okay, so those projections should kind of reflect the actual reality on the ground, because the people who are vetting these applications or are conducting interviews are again experts in their own field and they know the ground reality. So very important that you put a realistic number when you are defending your case. Understand whether it is a concentrated market or is it an established market or it is a niche market, and then accordingly you design your strategies. Then you should always highlight the interaction with the clients or the third party in the application. So a third party validation on your product, right? If you are say for example working say on apple pomace. Okay, apple pomace, as I mentioned, is a huge pain point and to the these industries, and there are a lot many solutions available, like for extracting the pectin. Pectin is a compound which is having various industrial applications. So if you can provide a technology which is extracting pectin in a cost effective way, and that process you have kind of validated, even a partial validation with say a apple juice manufacturer you have carried out, and that has the uh, you know uh, validation or certification from say a NABL accredited lab. So if you are going with that homework to the investors, so that is very much appreciated and it increases your chances of availing the funding. Then finally the team. So you should look for a diversity in your team. Try to bring your core team for the interview wherever you are going, and I would suggest that you can have an academic mentor from a premier institute. That kind of adds as a a further validation to your technology. And also try to have a business or a marketing mentor, which is also very much recommended. So this is in short a few traits of an application in the agri-tech space, which may increase your chance of getting selected. So again, how to do this? I mean, if you have to start your own venture, the best way is to get incubated, then apply for fellowship and the accelerator. There are lot many accelerators which help if you are working on say carbon, saving the carbon emissions through your agri-tech ventures. So there are lot many national and international accelerators available to kind of facilitate your or expedite your growth. So it starts with the government funding platform. I'll quickly go through since this is a recorded session, so you can obviously have a look at these These are various funding agencies which are being provided through BIRAC. Then these are various schemes which are being run through DSIR. Then the DST also runs through this TDP board and NSTEDP. Then SEDB offers a lot of options for loan to your venture. Then there are IPR and market assistance funds for the MSMEs, and this is facilitated by the Department of Commerce and Industry. And again, there are many international programs which are specifically catering to the agri-tech space. So you can visit some of these programs and understand whether it aligns your with your scope. So again, this is the funding which is provided by BIRAC. So again, I mean, we have different uh, pointers here, like the innovation index, the developmental stage, the eligibility, the grant in aid, and other things, other requirements. So then after this comes the angel funding or the venture capital funding. So here also you can kind of apply once your technology has reached to the development or the commercialization stage. So I mean, there are a lot many platforms available which includes funding information from these houses. Okay, so I'll not spend much time on this. So the take-home message is that being an entrepreneur is not easy, and it requires being extraordinary in an ordinary world. And it is very important to get out of your comfort zone, and start taking the risk, and addressing the challenges. And it is very important to network, you know, uh, especially in the agri-tech space, where such challenges are there. So now since we have a limitation on the time, so we'll quickly go through what we are doing at Fermentech. Just a glimpse is that we work on a circular economy concept, where we kind of convert these agricultural waste primarily into metabolites, and the end residue we convert into fuel pellets. So these are like some of the enzymes that we have developed, like pectinase enzymes from orange peels and wheat bran. Then this is all done using some fungal microorganisms. Then amylase we have developed from waste wheat bran, and amylase finds various applications in bakery, then pharmaceutical, then starch desizing, then clarification in fruit juice and beer. Then we also have a product called xylanase, which we have made from sugarcane leaves, wheat bran, some linseed oil cake, and again it is having wide applications in the animal feed, then pulp and paper industry. Then it is also used in fruit juice clarification, then laundry detergents. Then we have our front runner enzyme, that is cellulase, which we have made from again dried pine leaves, and we are currently supplying it to the textile industry, which are using in their biopolishing and other processes. So these are some of the examples that we have demonstrated how you can convert agricultural residues into high value metabolites. Again, it is very important initially to focus on a product which gives you higher returns. So once you establish that business model, you can also kind of try out the side products, right? So that is something that you can do. So uh, madam, if there are questions, I would be happy to take. uh,
Okay. Okay, Mr. Siddharth. So thank you for the brief presentation. Now I'll take up some questions. Just 1 second.
Yeah, yeah, sure.
Okay. So the first question is, what types of agro-industrial waste have the highest potential for value addition?
Okay, so that's a good question. See, basically, you have to, study some chemistry behind the agro waste. Say, for example, uh, you have to ascertain or determine what we call as the holocellulose content, that is the hemicellulose and the cellulose. So if a raw material is having a higher, cellulose, hemicellulose content, so which means that, it has a higher repository for that to be converted into some value added product through fermentation. Okay. Uh, so that is one criteria, and there is a method called proximate analysis which you can use to determine this particular content. So that is how you can kind of work around, to determine which particular agro waste can be used. For example, like paddy straw sometimes is not a very good raw material for fermentation, given its very high silica content. So again, so that is something which you have to take into consideration.
Okay. And how can farmers convert crop residues and byproducts into profitable products?
See that maybe biofertilizer is one option where lot many startup companies and other companies are providing with certain microorganisms or consortia of microorganisms, and very simple equipment are also available to kind of convert these waste. The idea is to kind of mix those microorganisms with these waste, and give it a certain moisture content or a water content, and let it ferment in a pit for uh, few days. So that is one method where how farmers can in a very cost effective manner can convert these residues into biofertilizers.
Okay. What simple technologies or fermentation methods can be adopted at small scale?
So solid state fermentation is one such method which can be adopted at a a farm level or a small scale. Again, as I mentioned that you have to see uh, what all microorganisms or a consortia is available in the market for a particular raw material or agro waste. So although it will require certain investment, but uh, that is something which can be planned or look forward to, given that the quantum of agro waste generated is higher, significantly higher, that may give you a return, uh, say for biofertilizers, or selling those biofertilizers in the community. So that is how one can look forward to.
Okay. Um, what are the economic returns from waste valorization at farm level?
Actually, I have, see, I'm not, very, I'm not the very right person to answer that question because our operation is usually restricted to the B2B sector. So whatever products or the enzymes that I have shown that we are, producing, we are directly, selling those enzymes to the industries, particularly textile industry or fruit juice industry. So we have not specifically ventured out to assess, the unit economics when it comes to valorization of these agro waste at the farm level. So I cannot exactly comment, but yes, I can tell you that it is a number game. It is a scale game, and uh, given that significant amount or tonnage of waste is available, then only it may be kind of profitable business uh, for conversion of that agro waste into say fertilizers, because again equipment and maintaining some sort of control may be very much expensive or unaffordable for a say average rural household. So these are like questions which are need to be addressed, and maybe more uh, experienced and qualified person in this particular sector will be able to give you the right answer.
Next question is, how can waste conversation, sorry, how can waste conversion help in reducing pollution and improving soil health?
Okay, yeah, so that is again a good question. See, there is a misconception that, by burning the, waste like paddy straw or any agricultural waste, increases the soil fertility, because when you are, incinerating these, agro residues, you are basically also, destroying or, killing the useful bacteria which are, present on the, soil surface on 2-3 centimeter of upper soil surface. So that is also, getting destroyed as a result of those incineration. So, incinerating is obviously, it is destroying the soil microbiota as well as the air pollutants which are being, released into the environment are, everyone knows it results in detrimental air qualities and, toxicity in our, cities and, villages. So it is not at all recommended or advisable. The more prudent solution is to kind of use those waste as a raw material, and to convert those into preferably high value metabolites is more preferable.
Okay. What role do microbes and bioprocessing play in waste transformation?
Yeah, so they are the key players. Like they are the like biocatalyst. What they do is like they basically consume these waste, and they secrete certain enzymes. When they secrete certain enzymes, these enzymes are hydrolytic in nature, and it is a complex enzyme mix which contains like cellulases, hemicellulases, some peroxidases also, then certain other ancillary enzymes also, which collectively act on the raw material, and by the hydrolysis action it breaks these polymers like cellulose into simple sugars like glucose, which the microorganism uptakes for its energy generation, and in that way it kind of multiplies and consumes the agricultural waste. So that is the mode of action for the microorganism. Now it is very important that the moisture content and the nearby pH content is suitable for the microorganisms to thrive, or to enable it to kind of efficiently degrade the raw material. So that is where the question of providing a localized environment or a simple equipment comes into the picture to kind of facilitate the growth of these microorganisms, which is very critical for the bioconversion or transformation of agricultural waste into value added products.
What are the major challenges in setting up waste-based enterprises?
See, the one thing is, it is sometimes a capital intensive process. So if you are talking of waste, so uh, most likely you are going to generate some biofertilizers, which is again a low cost product. So to to have to ask for investment for generation of a low cost product, so that is one of the major challenges in setting up these waste generation plants. uh, but if you are looking at other products, other high value products like enzymes or some prebiotics or some probiotics or some maybe biogas generation, then the unit economics is much better. But at the same time it requires much higher capital intensive machinery and the control system and the human expertise. Then also there is another angle on the finding the right type of market for these products. Sometimes the right market for these products is far away from the uh, source of generation for these waste. So to establish and optimize the supply chain is also very critical while you are addressing the waste conversion into some high value products. So these are some of the key points that you need to keep in mind. See, I mentioned the press model at the very start. So it applies to all these aspects. So the problem statement, obviously, I mean every agro waste, if it is landfilled or incinerated, is problem for one or the other stakeholder. But then you have to also take it into account whether it is giving a positive business model resulting in revenue, right? So or not. So by revisiting and reassessing the press model, you can kind of maybe take a wise decision on which type of waste to valorize, how to valorize, and into what to valorize. So this would be my suggestion.
Okay. And next question is, mm, yeah, how can FPUs or rural youth benefit from agro waste startups?
So they can be a very important part of the supply chain. That is one thing. To ensure a consistent and quality supply chain of the raw material to the processing plant, and also for the supply chain of the ready products to the industries or the end consumers. So that is one thing which the which can create tremendous opportunities for rural employment. Likewise, there are ancillary products or side products that can be generated, since it is a complex material. It contains lignin, it contains cellulose, it contains hemicellulose, it contains certain maybe flavonoids, certain phenols, you know. So it's a very good prospect for a biorefinery. So uh, so there is always a potential to kind of diversify, get a diversified product, and the rural community can then be trained in these diversified sectors to kind of uh, have a business out of it, or generate employment around it. So that is I firmly believe in. We are basically associated with around more than 40 farmer households, for the procurement of various agricultural residues. So that is like that is how we are contributing, and we have seen how we can kind of provide certain returns to the farmer households. So currently we are focusing on one product, but if this is converted into a biorefinery, where many industries and many companies are now striving for, so this can add multiple avenues to create more job opportunities for the rural community.
Okay. Are there any government schemes or funding support for such initiatives?
There are lot many initiatives, lot many schemes. I had mentioned in our uh, you know in my slide that uh, like DBT, Department of Biotech, BIRAC, is supporting uh, such initiatives. Then there are uh, schemes of DST, then MIT, then DSIR. There are so many uh, schemes that are out there available. So I've shared that in the presentation. So the interested participants can just give me a second, huh? Just give me a second. I'm getting an
Okay,
important
sure.
call. Sir, I'm in a meeting. Can I call you in 10 minutes? Yeah, yeah. So that is how I mean, I've shared that in the presentation. So in the recording, you can have access to all that information.
Okay. And so we have the last question. What future opportunities do you see in bio-based and circular agriculture models?
So there's a huge opportunity. There's a huge opportunity, and uh, as I mentioned, a single agricultural waste can be transformed into multiple products. So if I give you an example of lignin, it is a polyphenolic compound where it has so many phenols, ketones, aldehydes, and other aromatic compounds, which currently today we are extracting from, say, crude oil. So just to give you an example, so many specialty chemicals can be derived out of lignin, which is a major component of any agricultural waste, which provides it the strength. Likewise, we have a lot of cellulose, hemicellulose in the agricultural waste. If we have cost-effective technologies to convert it into, say, 2G ethanol, so a lot of 2G ethanol, or say, sorry, a lot of ethanol today, that is 1G ethanol, is diverted from sugar. So, but there the question of food versus fuel comes. So, if you can develop a technology which has a cost-effective method for converting these lignocellulosic biomass into 2G ethanol, so that adds a lot of additional ethanol, and it increases the the Make in India theme also, and provides you a lot of subsidies and incentives, and you can make it a big business. So these are like some of the examples. Lignin is now called as the black gold, like, so you can do so many things. So people are making batteries out of say agricultural residues, sodium ion batteries. So there is a potential is huge with the valorization of the agricultural residues.
Okay. Okay, Dr. Sidharth. So before we end, one last question. Please let us know a little about your career background and what made you to start this company.
Sure. So I am a BTech, MTech in biotechnology. I've done my MTech from NIT Surathkal, industrial biotechnology, and post that I had joined IIT Roorkee for a doctoral program, where, as I mentioned in the beginning, my job was to work on bioreactors which operate on solid state fermentation, converting these agricultural residues into high value byproducts like enzymes. So during the PhD days, I could see the potential that these agricultural residues, given the enormous quantity available, the potential of these agricultural waste and industrial waste to be converted into enzymes. And since mostly all the enzymes, we are highly import dependent, with few manufacturers in India. So we could see the potential if we can scale this up with the right engineering acumen and the right skills. So this can be converted into a highly profitable venture with the tremendous opportunity for creating rural employment, and also to save the imports. So these were the major motivations to kind of start the venture after assessing the technological feasibility at the PhD level. And at the same time, while I was finishing my doctoral research, a lot of support from the government also came through various schemes, as I mentioned, through incubation centers and other instruments to provide funding, legal, then network, and then marketing support to the startups. So all that kind of precipitated into starting venture and taking it forward.
So on behalf of agricultureinformation.com, we'd like to thank you for the presentation and answering all the questions. So we'll be ending this meeting now. Have a good and good day.
Thank you for hosting me. Thank you. Good day to you.